tau. And what it means. It's a very quick, but only an approximate understanding of how long it takes to discharge. We know that in truth, our intuition up here on the upper right says it takes an infinitely long time to discharge. But yet, surely there's differences between things that are maybe 99% discharged in a microsecond and things that take a year to discharge 99%. And that tau gives us that understanding. And here's how it works. Remember that we just said that V of t is equal to our initial value times e to the minus t over tau, where tau is equal to RC. So here's an example. We've got a 1 microfarad capacitor connected to a 100 ohm resistor. And I'm going to say that VC, I'll define my VC over here. And say VC is equal to VC at 0 is equal to 90 volts. And therefore, I can write my full equation right now. That the voltage across the capacitor at any time is equal to 90 times e to the minus t over tau, where tau is equal to 1 micro times 100, which is just 100 micro, and the units are seconds. So we could graph this. We know it goes down like this. We know it starts at 90 volts and decays down from there. And we know it eventually will be at 0. But really fast, when is it half discharged? When is it, say, I'll go even further than that. When is it 99% discharged? There's two ways to answer these things. Exact and using time constants. So if we want to measure exact, we'd have to write an equation. If it starts off at 90 volts, it'll be exactly discharged halfway when it's 45 volts. So we would plug in 45 into our equation of 90 e to the minus t over tau, where tau is equal to 100 micros, and we'd solve for t. And you could do that. I mean, I'll start you off on it. So we divide both sides by 90, we'd get 1/2 is equal to e to the minus t over, let's see, that would be, let's see, 1 over, I'm going to just write this over here. 1 over 100 micros is equal to 1 over 100 times 1 over a micro. That's equal to 0.01 times what's 1 over a micro? Dantre?
So I remember your analogy when you say you got to move up 2 from the
yeah, that's right.
Position.
That's right. So we're starting off at our 1 position, milli, micro, nano, pico. So we're currently 2 down, so we're going to have to move
up
2 up. And a 100th of a mega is the same thing as 10 kilos. So we could rewrite that as this, and then you'd take the natural logarithm of both, and you'd find that taking the ln of both would give us ln of 1/2 equals minus t over 1,000. You'd multiply both by sides by minus 1,000. You'd solve for t. Okay, that's the way a mathematician would do it. As an engineer, we say it half discharges a little less than tau. And so just by inspection, it's a little less than 100 microseconds, and we walk away. That's pretty cool. So this is something that you should know, is that the tau refers to when it's a little less than halfway discharged. I guess exactly, it's discharged to e to the -1 in tau, which is about 0.35, I think. It's just a little less than tau. Here's another one. When is it 99% discharged? Exactly, you do the same thing over here. You say it's 99% discharged when it's 0.9 equals our equation, and you do all the algebra, and it would take a while. But as an engineer, we say it's 99% discharged at 5 tau. So just by inspection at 500 microseconds or half a millisecond. No nasty algebra required. So it's really common to look at a circuit like this and to say, hey, when is it mostly discharged? And the answer is always going to be 5 tau. Any questions on that?